wait করব কি স্যার? স্টার্ট
না
করব?
না না শুরু হ্যাঁ স্টার্ট।
So good morning, students. Today we will be conducting the first lecture session of the series on algorithms for problem solving. And we are privileged to have with us Professor Shopon Bhattacharya, who will be delivering, who will be talking in every session of the series. So before we begin, I would like to give a brief introduction of Professor Shopon Bhattacharya, sir. He is presently associated as a professor in the Department of Information Technology of our university. He is a former professor in the Department of Computer Science and Engineering, Jadavpur University, Kolkata, from 1997 to 2017. He has also served as a director of National Institute of Technology, Surathkal, from 2012 to 2015, and also as a director of National Institute of Technology, Durgapur, from 2005 to 2010. So I would now like to request sir to please begin the lecture session.
Thank you, Dr. Somdatta. Good morning to you all. I'm audible, right?
Yes, sir.
Yes. Okay, good. So once again, good morning to you all, students. It's a pleasure to be talking to you, but of course, the pleasure would have been much more if we could interact as we normally do in the physical platform, where I can see you all. But okay, we have to live with it, depending on the current scenario. But I'd like to thank Macau for providing such a wonderful platform. I hope it will work till 1 hour. So before I proceed, I'd like to give a brief preamble. As a student, teacher, researcher of algorithms, software engineering, data analytics for more than maybe 25 plus years, I do always believe that algorithms is one subject which should be taught to the students right at the school level. Just like a student is taught geography, history, maths, science, similarly, algorithms should be taught right at the school level. And a student of every discipline must have some idea, some background knowledge about algorithms. So in this series, I'll be with you for several sessions. I think, I don't know how many, but let's start. So first 2-3 sessions, I will dedicate on why everyone of us, everyone in the society, mainly the students, teachers, should have some knowledge about algorithms. I'll try to explain that. And also, I would try to introduce some of the background terminology that would be required to understand algorithms in particular. So why algorithm? Essentially, the study of algorithms will help you to understand, analyze a problem with rational, logical, and analytical mindset. Again, knowledge of algorithms will help you to study and analyze any problem you face in life with rational, logical, and analytical mindset. Now, by life, I mean family life, social life, academic life, professional life, even if you are in startup management. So let me discuss some examples to start with. Let's think of family life. Every one of us, mainly our mothers, grandmothers, they used to cook very nice. What do? They have many ingredients in front of them, many spices. Depending on the item to be cooked, they mix up, follow a process, and come up with a delicious item. In the background, let us also get introduced to the terms which we already know by this time: artificial intelligence, machine intelligence, in IoT, and all those. So think of a robot. If we want to develop a robot for cooking, what do? Remember, a computer cannot do anything which human beings cannot do. Very clear. Whatever latest generation, latest version of computer it may be, a computer cannot do anything which a human being cannot do. Then why do we use computers? Because the computer does it very fast, can do numerous times with same accuracy, and they have practically infinite memory. But again, they cannot do what human being cannot do. Number two, computer doesn't have any intelligence. Computer doesn't have any intelligence. It cannot make a decision of its own. We have to train the computer to take a decision. We have to train a computer to take appropriate decision at any point of time. Simple example. We all have so many languages: English, Hindi, Bengali, so many natural languages. Then why do we need special languages for usage in computers? Simple. Natural languages cannot get rid of ambiguity. Just think, meaning of a particular word may vary depending on the context, depending on how it is used, depending on the accent we are using it. But computer cannot make out all these differences. However, computer can be trained to do a particular job, but again, it has to be trained. And again, we can train a computer only if we understand the problem rationally, logically, and analytically. And here is the importance of algorithms. I'll come to it as the series unfolds. As we all are aware, and as a student of software engineering, I can also say that most of the problems emanate out of our lack of clarity in understanding the problem. If you go to a medical practitioner, if he or she understands the problem first, then the diagnosis becomes very easy. Let us take another example. When you drive a car, you have to regulate the speed of your car depending on the speed of the car ahead of you as well as the car behind you. If you want to overtake a car, just see how much computations you do, probably unknowingly, before you take the decision to overtake. When you approach a crossing, you see the signal. Depending on the color of the signal, just imagine how much computation you do in the back of your mind to regulate the speed of your car. Given in a simpler way, once you think of crossing the road, say in Calcutta or anywhere in India, what do? First, you look at the right, then look at the left, and then look at the right again, and then you cross. This is the sequence you follow. Probably you think explicitly because you are so much accustomed. You are so much accustomed with this. But this is what you are doing. This is what you are doing always. Today, it's almost clear. But remember, for crossing the road or driving in the road, if you do the same thing in US, you will do it differently because they follow different rules. They follow different rules. So whatever approach you do depends on the environment also, depends on the rules which are followed there. Think of any problem in any issue in academia. Let's think of any student who is in geography. She studies flow of rivers, maybe a little bit of environment and all those. And everywhere, she has to think why some particular events are like that only. As for example, if you study the environment in India, you will see most of the polluting areas are also during the course of river Ganges. Why river Ganges is so polluted, whereas Godavari and Tapti, Narmada are not to that extent. Similarly, if you study history, whatever subject you study, you will find always you are facing problems. But we are so accustomed with this in our daily life, we generally do not give particular attention to what we are doing in the background. Think of in your professional life, human resource management, financial management. Think of how the stock market operates. Having given the price of one particular stock at any point of time, somebody is buying, somebody is selling, but everyone has some rationale behind the decision he or she is taking. So coming back to the point again, algorithm helps you in understanding rationally, logically, and analytically any problem you encounter. So that means study of algorithm helps you to become a more successful person in whatever way you work. The same, what I am saying, may be looked at from a different perspective also. Some of you, in fact, many of you must be singing as well. Whatever you sing, Tagore song, folk song, typical cinema movie songs, you cannot go beyond a certain level until and unless you have at least some grasp on classical music. If you see great singers, most of them, they are good classical singers as well. If you play soccer, whatever position you play except probably goalkeeping, you learn the art of receiving and shooting. These are the absolute fundamentals. These are the absolute fundamentals. So similarly, whatever be your area of study, whatever be your area of profession, algorithm has to be in the nucleus. It has to be in your mindset, to the extent when Sachin Tendulkar makes a cover drive, it comes automatically. He does not have to even think before that. Similarly, as you develop yourself as a successful professional or academician, which you will, I'm sure, if you have proper background of algorithms, you will handle the situation in a completely different way from others who do not have any background of algorithms. When I joined profession in an industry, civil engineering industry, long time back, one person, a senior person, told me when Howrah Bridge was built, there was no computer, but it's still standing. Today, why do we need computer to build bridges? Analogically, I give that example of the cooking I had given you earlier. At home, we get delicious food prepared by our parents and grandparents. Can you do it yourself? Having given all the ingredients, having followed how it is cooked 100 times, can you do the same thing? No, we cannot, because we do not have complete absence of ambiguity. We have to do it in every step. We have to do in such a way that we can interpret every step uniquely. In this context, we should understand very clearly the difference between the word computer and computing. In many cases, I find there is lots of confusion in the process. Computer is a tool. Don't forget, computer is a tool. Computing is a process. Computer is a tool. Computing is a process. When you cross the road, you do some computing in the back of your mind on how long you should take to cross the road, how long should the car take in approaching. That is computing. And computer is the tool which is very useful, for getting the computing implemented. Just like say in a refrigerator, compressor is there, but you are using the refrigerator in different ways. The car, you have the tool inside, but you use it in a different way. So when I say everybody should have knowledge of algorithms, I am relating algorithms in the context of computing. Extensive study of computer as a machine is predominantly within the purview of computer science and engineering, and to some extent, to a major extent, within the purview of students of IT as well. But so far as computing is concerned, everyone has to have some clear idea about what is meant by computing. In fact, the theoretical aspects of computing are generally covered extensively in the disciplines of mathematics, statistics, basic science. So this we have to appreciate before we proceed further. I take 2 minutes gap if you have any queries.
Yes, if you have any queries, you can raise your hand, students, or you can write in the chat box also.
So it's audience is too big, but okay, we have just started, so there may be some queries as we go ahead further. Okay.
There were several raised hands.
Okay. But
yes, ma'am.
Yes, you can ask one at a time.
Saptarishi Mandal.
Yes. Which department? Please mention.
Saptarishi Mandal, if you have any question.
Please unmute yourself, Saptarishi.
Saptarishi Mandal.
Let's go ahead and then we will.
Sir, there are questions in the chat box.
Go ahead.
Is coming in the question answer section. So what is computing? Asked by Labani Hembram.
Okay. And any other question?
Yes, sir. Sir, what? Yes, sir. Nitai Sutradhar. Sir, what pre-knowledge I should have for computer vision learning?
Okay. Okay, fine. What is computing? Yes, this is the crux of our discussions. Without that, we cannot go ahead with the algorithms. First of all, we have to understand the difference between a computer and a calculator. A computer and a calculator. What is the difference? Calculator only calculates and computer computes. What does it mean? Think of a calculator. You are supposed to add 100 numbers. How do you do? Type the numbers and add plus sign and you get the result. If you want to do the same thing in a computer, what do? You write a 3-line code and then input the numbers. So, what is the difference? Just think carefully. While calculating, you have to type the plus sign also 100 times. Whereas in computer, you don't have to type plus sign 100 times. You have to type it only once. That means a calculator can store only data, whereas a computer can store data as well as instructions. Again, a calculator can store only data and a computer can store data as well as instructions. This is known as stored program concept. We'll try to discuss this further in course of our time later on. So what is computing? What computing is basically articulating a problem in the form of data and instructions. Instructions may be logical, arithmetical, relational. All these we'll explain later on. But at the basic level, computing is an approach to solve a problem. Someone has asked about image processing. Again, everywhere we hear AI, ML, IoT, be very careful. Don't get carried away by whatever is pushed through by the media. What is artificial intelligence? I'm just moving a bit out of our major theme, but this is very much related to our theme. What is natural intelligence? Have you ever asked yourself before studying artificial intelligence, what is natural intelligence? When a baby is born and she learns how to stand on her feet, who teaches her that? Nobody. That is natural intelligence. In your school days, remember, in many cases, when you solve a problem, mainly of arithmetic or whatever, you don't follow any book. You do it from your own. So what you do it naturally is natural intelligence. Then what is artificial intelligence? There, having given a problem, you maintain a huge database in the background. Huge database in the background. And when a problem comes, you try to match this particular instance of the problem with some instance already available in the database and try to take help of how the problem was solved at that point of time. Since computers can process much faster, have almost infinite, huge amount of memory, computer can handle this job much, much better than a human being. But computer cannot innovate. Computer can help us in innovation. That is a different ball game altogether. Just as the example of the cooking I had given, if you have a database, of thousands of items, step-by-step process, how to cook it, and then you can train a computer, you may call it a robot or whatever, having given an instruction to prepare one particular item, that computer can search out of that huge databases, make some changes, but that changes also you instruct the computer to make, and then you get it done. So in that case, the product, the output will be independent of the person who is developing the product. Again, just আমি একটা টকে আছে হ্যাঁ একটা টক দিচ্ছি so it you see very commonly when you buy any shirt or any item, handmade items are always much more expensive. So this is the difference between computing. I've already told you, just introduced you about stored program concept. This artificial intelligence, now you at least understand the meaning of the term. Intelligence put to use on the basis of experience. And we also program the machine in such a way, that the number of instances in the repository keeps on increasing. It's a huge subject to study it in a different, but again, then what is machine learning? Now we know machine means, here I'm talking about computer. Computer cannot do anything of its own. So if you want to get something done through the computer, you have to make it learn. You have to make it learn. Again, it's a huge subject, but basic philosophy is how to make it learn based on previous knowledge, or can it develop some derived knowledge out of whatever you have in the repository. IoT is also a similar thing, but we will give that example in IoT later on. So coming back to the initial point I make, why should we study algorithms? We study algorithms because it helps us in developing appropriate mindset to analyze any problem we face rationally, logically, and analytically. Think of any home science application. In a room, you have to put your so many furnitures. What is the best combination? What is the best combination? Again, a typical problem. with so many constraints, with so many boundary conditions. How do you do that? I take just 1 minute break again. Next, to get ready to study algorithms in proper depth now, we have to also understand what some associated terminologies which we may have to refer to during the course of our discussions. Again, I always give examples. If you play cricket, of course, you need to know how to bat or ball. But to be a successful cricketer, before going to the field, you also need to know how is the pitch condition, how is the weather condition, whether you are playing white ball or red ball, and so many parameters. In course of discussions on algorithms, we'll be using many terminologies. One I have already used, which is known as stored program concept. Basically, a scientist by the name of von Neumann, V-O-N-Neumann, had introduced this. But again, it's a bit difficult. We'll come to it later on. Let us try to demystify some of the terms we use very commonly, but we do not know what it is. First of all, we use the word system. What is a system? Every now and then, people refer to a system. What is a system? How do we define a system? What are the characteristics of a system? Okay. A system will have inputs, outputs, processing unit, and feedback. Input, output, processing, and feedback. Need not have to be an engineering system, need not have to be a computing system. In any system, suppose we consider the system of answering a question paper. You go to so what are the inputs? Input is the students' question paper with marks and all those. What is the output? Marks allotted to each student. What is the process? Evaluation by the faculty member, paper setting and all those. And what is the feedback? What is the feedback process? How it develops? Suppose there are 10 questions and you are supposed to answer 7. Based on the information you got from your seniors, you have some idea about which questions probably will give you more marks than other questions. That is an example of feedback. And you appreciate as you move further, this feedback will keep on changing. If you go to some railway reservation counter to buy a ticket, what do? There are 4 counters. You stand in any one of the 4 queues. Input, output, processing is very clear. But how the feedback comes? Looking at the speed You prefer to stand in one queue instead of in another queue. This you develop through your feedback mechanism. Similarly, a computer is a system, of course. So computer will have some inputs, will have some outputs. It will have some processing unit, and it will have some feedback system. It will have some feedback system. And I'm not getting into the details here. Feedback system is very important in maintaining the stability of the system also. Mainly the electrical engineers are concerned with that. Our human body is a very complicated system. So I hope you understand what is the meaning of the term system. Then we use the word model very commonly. And the word formal model is even more important in the context of computers. So what is a model? Replica of some real life world. In many of your homes, probably in your living room, you have a model of Taj Mahal. You may have a model of Niagara Falls. If you think of a big complex, very big complex, some real estate developer creates a model so that prospective buyers can look at it and have some idea about how it's going to look like when it's completed. This is a model. But looking at the model of a building, can you know whether this building would be a residential building, commercial building, or a hospital? No idea. If you put a red cross in the building, now you know this is going to be a hospital. And then it becomes a formal model. Again, please remember this very clearly. What is a formal model? A formal model must have the characteristic, one characteristic. What is that? Interpretation of the model should be independent of the person who is interpreting it. Interpretation of the model should be independent of the person who is interpreting it. When we talk about computers, it is a machine. It cannot interpret on its own. That's why whenever we want to work on a model and use a computer to be built on the basis of that model has to be a formal model. And that is the reason why we need special languages for computers. Think of natural languages, Bengali, English, they all have grammar. This language C, Java, they also have grammar. We call it syntax or whatever. But what is the problem? Grammar of English is not formal. In the sense, having given a particular sentence, the interpretation of the sentence may very well vary drastically depending on the person who is interpreting it. In a lighter vein, it is said, if a language can be used in the court of law, then it cannot be used by a computer. Because in the court of law, we have such a huge establishment basically working on the interpretation on a particular sentence. Again, I'm saying, please do remember this, that for any application to be developed and for which we have to use computer, the underlying model has to be a formal model. And what is a formal model? Where the interpretation of the model does not depend on who is interpreting it. In fact, this is the underlying concept of algorithm design in the background, of course. In fact, let's get down to even further basic level. When we talk about computers, we talk about nowadays predominantly digital computers. Are we really aware of the difference between a digital and an analog machine? Analog is continuous and digital is discrete. Analog is continuous, digital is discrete. Having given, say, one straight line, and you are supposed to get the length of the line. If you use an analog device, you have to use your sense, imagination a bit to come up with the exact length. On the other hand, if you use a digital technique, you do it in terms of discrete, smaller blocks. Digital means discrete, analog means continuous. For any measurement process, analog has the potential to be more accurate. I'm using the word potential very carefully. Why? Because this is dependent on, very much dependent on the person who is measuring it. On the other hand, if you use a digital technique, again, depending on the extent of the technique you're using, digital may not be that accurate, but it can be very close to that in terms of accuracy. But one thing is very sure, that the result will not depend on the person who is measuring. Result is independent of the person. Think of a scenario where you want to, say, go to Burdwan from Howrah. There could be 5 trains a day, but you do not know the timing. On the other hand, there could be 2 trains a day where the timing is known. Second scenario is generally considered to be much better. So again and again, what I am trying to impress upon you is trying to deploy machines to help us in solving our everyday problems. And it is pretty sure, at least, say, during next 10 years, topics like AI, ML, IoT, all these are going to stay. In fact, mechanical engineers, they have to study IoT more than information technology specialists. Those who are in bioscience, they have to use these tools probably more than the computer science students. So all these, we have to be very careful. Now, my final remark for today, again, I get back to the word I said in the beginning, why we should study algorithms. Everybody. And with the difference that anybody who wants to sing must study, must learn classical music. But someone who wants to make a career in classical music is one thing. Someone who wants to make a career in maybe film song is another thing. But irrespective of whatever be their ambition, they have to study algorithms. Maybe the depth span that may vary. Why? For algorithms, now we can easily see that we are in an era of convergence of social science, life science, and computing science with technology as the driving force. Social science, life science, computing science with technology as the driving force. Till about a couple of decades ago, computing was mainly restricted to scientific applications. Mainly restricted to scientific applications. Think of any applications more than 2 to 3 decades back. But today, it is not so. We are trying to apply computing for social science, life science, and computing science. But there's a major difference between the underlying guidelines of a problem in computer science or a problem in basic science versus a problem in social science. What is that? In basic science, if you say X is greater than Y and Y is greater than Z, this means X is greater than Z. Clear? In social science, if we say X loves Y and Y loves Z, does it mean X loves Z also? Just a moment. Just a moment. Hello? আমি একটু বাদে ফোন করি তোমাকে একটু So if X loves Y and Y loves Z, does it mean X loves Z? It may be yes, it may be no, it may depend on the context. But we're trying to use computer there as well. If you think of physics, P equal to mf. Very clear. If we send a satellite today, even after traveling for thousands and thousands of miles, we can predict with almost 100% accuracy the trajectory of the satellite. Think of life science problem. You have fever, go to a doctor. Doctor gives you paracetamol and tells you that you will be cured in 7 days. Can you ask the doctor to draw a curve to see how the temperature will come down? Doctor will tell you not to visit him next time. So, in basic sciences, the problems are much more structured. Whereas in social science, life science, those are mostly unstructured. And also, in basic sciences, generally, we work on deterministic process. We want the optimal solution. Whereas in social life science, we are more interested in satisfiable solution. And satisfiability depends on the individual. Optimality does not. If you go to a doctor to get your fever cured, are you that serious that it has to be cured by 6 days, 7 hours, 20 minutes? But think of a satellite. There you have to program in terms of years, days, and months. On the other hand, we already understand that the computer cannot take a decision of its own. It has to be trained to take the decision. And how do I train it? Background is the algorithm. So the person who is developing the algorithm, she must be capable of understanding the problem and developing the algorithm in such a way it can solve the problem. Understanding all the associated parameters, like, do we need an optimal solution? Do we need a satisfiable solution? Do you want to do it very fast? Do you have any constraints on memory? And all those? All these have to be kept in mind. And that's the reason that each one of us have to develop a mindset to understand the importance of developing algorithms in a proper manner. I think we can conclude today. Dr. Samdatta?
Yes, sir.
Going
Yes.
beyond 1 hour may be difficult for the students.
So we can take the question answers?
Yes, of course.
Yes.
Of course.
Prem, can you just read out the questions?
Yeah.
Yes, ma'am. Ma'am, the question is in the chat box from Suman Ujha. Which
Give
book
me
should
the
we
background.
follow?
Which background, which department and which year?
Yes, sir. So, Suman Ujha, if you can write your stream and your course,
For any
then
question.
it will be easy. So the question was, which book should we follow for learning algorithm professionally as beginner? Second year branch CSC.
Yeah, he is here.
Yes.
I think if he unmutes himself, he can directly ask the question.
Suman,
Yeah.
just you unmute your mic.
Hello.
Yes, yes.
Sir, which book should we follow as a beginner professionally to learn the algorithms?
So you are in computer science?
Yes, sir.
As a computer science student, you must have at least 10 books on algorithms. Have you seen the almeida of any lawyer? How many books they have? Of course, I'll name some. But irrespective of your discipline, you must have 8 to 10 books on algorithms. Okay, I give you some names, and I'm sure your teachers in the department will also give more or less the same names. Coreman, very common book. Harvit Sahani is, there are 2 books, one on data structures and one on analysis of algorithms. For this course, it's better to have analysis of algorithms. So Coreman, analysis of algorithm, Harvit Sahani, Kleinberg and Tardos. This book is not that common in India now, but I would strongly suggest to consider this as the textbook. Both Kleinberg and Tardos, they are faculty members of Cornell University, and that book is written very well. In fact, I rate them as the number 1. Kleinberg and Tardos. Then there's another book by Sanjay Dasgupta and Papadimitriou. That is more on problems related to mainly graph theory and combinatorics. At least these 4 books you must have in your almirah. And please read algorithms and data structures, graph theory, combinatorics first before diving into the ocean of AI, ML, and all those. Don't get carried away by those big jargons. Don't get carried away by those jargons. Algorithms and data structure, concentrate on that.
Okay,
Yes.
sir. Okay, thank you, sir.
Okay, next. Next.
Sir, we have Jayanta Pramanik. Jayanta Pramanik, please unmute your mic.
You can go.
Jayanta Pramanik.
Yes, sir.
Yes. Go ahead.
Yes.
Which department? Which year?
I am first year from MCA student in Macau.
First year?
MCA student.
MCA student. Okay.
Sir, what is the difference between soft computing and hard computing?
What is soft computing and hard computing? Good, good. This we'll discuss in the next class. It will take some time to explain.
Okay, sir.
Please remind me, but I'm sure I'll remember that. Okay. But again, don't get carried away by those jargons. Don't get carried away. Yes, we need to understand the nomenclature. Yes, next.
Next, sir, Ankan Ghosh.
Department. Yes.
So I think he's left because of internet issue. Arijit De. Arijit De, please unmute your mic. Arijit De, yes.
Hello, sir.
Yes.
Good morning, sir.
Good morning.
Sir,
Yes.
my question is, sir, what is the
Again,
difference between...
which year? Which year? And
Mention
which?
your year and...
Sir, I'm from BSc IT, specialization in AI, from second year.
Okay.
Sir, my question is, what is the difference between algorithm and pseudocode?
Yes, very good question. Again, this we'll take up in the next class.
Okay, thank you, sir. Thank you.
Okay, yes, go on. Take it.
But he can listen to you, sir.
Is there?
Yeah, he's not
Origin?
here.
He can
He
listen.
can listen. Yes.
Just in a word, and since you are in IT, an algorithm has to terminate a program. I'm not talking about pseudocode, I'm talking about a program. A program may or may not terminate, but it may not be easy for general students to understand. So I will explain this in the next class. Okay, a program, an algorithm has to terminate, which is not necessarily true for any program. Yes, next.
Sir, Amiya Sarkar. Amiya Sarkar, please unmute
Hello,
your mic.
sir.
Amiya Sarkar. Yes.
Yes.
Sir, I'm Amiya Sarkar, Macau Teen House student, third year CSE. So
CSE,
my
okay.
question is the actual role of algorithm in data structure and database management system.
Okay, again, you are going ahead of time. We will discuss this in the next class.
No, thank you, sir.
We'll discuss this in the next class. Huh?
Thank you, sir.
Okay. Good. I do enjoy having questions. Any further question? So it seems that you are not sleeping.
Ma'am, somebody has asked for email ID.
Hello.
Regarding email ID, if you have any questions, you can directly write to the webinar ID and we will forward it to sir. Okay. Prem, you can just write the ID of the webinar team. So they can write to the webinar team and then we can forward it to sir for his comments. Or we will be listening to sir every week. So you can directly ask him.
Look, you can mail directly also, but after I take 3-4 classes.
Yes.
Because otherwise what will happen? Some of the questions you have asked right now, this we'll discuss in the next class. So it can be too premature for them, because in any case I have to answer so many mails every day. So so many mails. So maybe after several lectures, then it will be better. You can write to me directly.
And after the lecture sessions, they can always ask questions directly also.
Sure. So
I think, sir, we have...
Actually, the most challenging part for us is to make sure that at least most of the students are not sleeping. That is the problem.
Yes,
So it seems that at least some of them were awake.
Yes, it was a very interesting session.
Okay.
So I think we do not have any further questions right now. And so I would like to thank sir for spending some time with us from his busy schedule. It was really a very nice introductory session today.
We'll continue.
Yes, sir.
And before I conclude, I have one message for the students, that we are living through a very difficult time. I'm sure many of you are in very difficult situation in family, friends, and all those. So take adequate and appropriate care for yourself as well as your family members. Okay.
And one more announcement that I would like to make is the next session will be next week, same day, same time. Okay, sir. So we can close.